Imagine a world plunged into darkness, not for a day, but for years. A world where the sun is a distant memory, blotted out by a thick, choking cloud of ash. This isn't the plot of a disaster movie. This is the potential reality of a Yellowstone supervolcano eruption. The question isn't if it will erupt again, but when. And when it does, it won't just be a local event. It will be a global catastrophe. You've probably seen the maps online, the ones that show the entire United States blanketed in a thick layer of volcanic ash. A giant, ominous bullseye centered right over Wyoming. They show cities like Denver, Salt Lake City, and Billings buried under several feet of ash. Further out, places like Minneapolis, Kansas City, and even parts of the West Coast are covered in inches. The scenario looks grim, apocalyptic even. But how accurate are these predictions? Is this really what we could expect if the Yellowstone supervolcano were to blow its top? Let's separate the Hollywood hype from the geological reality. First, let's understand what we're dealing with. Yellowstone isn't your typical cone-shaped volcano like Mount St. Helens. It's a caldera, essentially a massive crater left behind by previous super eruptions. The last one, about 631,000 years ago, was one of the largest volcanic events known to science. It ejected over 1,000 cubic kilometers of rock and ash into the atmosphere. To put that in perspective, that's about 1,000 times more material than the 1980 Mount St. Helens eruption. So yes, the potential for a massive continent-altering event is very real. Now back to those ashfall maps. They are often based on computer models that simulate the eruption, taking into account factors like the size of the eruption and prevailing wind patterns. These models are our best guess, and they consistently show a widespread distribution of ash. The immediate blast zone, within a radius of about 100 miles, would be completely annihilated by what's called a pyroclastic flow. This is a superheated, fast-moving current of gas and volcanic matter that incinerates everything in its path. There is no surviving a pyroclastic flow. Beyond that initial zone of total destruction is where the ashfall becomes the primary hazard. Let's look at a city like Denver, Colorado. The most common maps show it receiving several inches, maybe even up to a foot of ash. What does that actually mean for the people living there? A few inches of volcanic ash might not sound like much, but it's not like snow. It's heavy, abrasive, and corrosive. When wet, it becomes as dense as concrete. Just a few inches of wet ash can be enough to collapse roofs, especially on older buildings or large, flat-roof structures like warehouses and supermarkets. The infrastructure would grind to a halt. The ash would clog engine air filters, rendering cars, trucks, and trains useless. It would contaminate water supplies, making them undrinkable. The fine, glassy particles are incredibly harmful to breathe, causing severe respiratory problems for anyone without proper protection. Power grids would fail as the wet ash creates short circuits on transformers and power lines. Essentially, a city like Denver would become uninhabitable almost overnight. It wouldn't be buried like Pompeii, but it would be paralyzed, isolated, and incredibly dangerous. What about cities further away? Let's take Chicago. It's over 1,000 miles from Yellowstone, but models still predict it would receive a dusting, maybe an inch or so of ash. An inch of ash is still a major problem. It would disrupt air travel nationwide, possibly for weeks or months, as the abrasive particles can destroy jet engines. Agriculture would be devastated. The ash would smother crops, and livestock that ingest it would suffer from severe health issues. The economic impact would be staggering, rippling through the entire country and, indeed, the global economy. Supply chains would be broken, leading to widespread shortages of food and other essential goods. So while the most dramatic maps showing the entire country under a foot of ash might be a bit of an exaggeration for a typical super eruption scenario, the reality is still incredibly severe. The United States would be effectively split in two, with transportation and communication across the ashfall zone becoming nearly impossible. But here's the crucial part of the story that often gets left out: the long-term global effects. A supereruption of this magnitude would inject massive amounts of sulfur dioxide and other aerosols into the stratosphere. These particles would encircle the globe, reflecting sunlight back into space and causing a significant drop in global temperatures. This volcanic winter could last for several years. Growing seasons would shorten or fail entirely, leading to worldwide famine. The delicate balance of our global climate would be thrown into chaos. It would be an extinction-level event for many species and a challenge to human civilization unlike anything we have ever faced. So, is this our inevitable future? Will we see this in our lifetime? Luckily, scientists do not expect her to blow for another 60,000 years. However, the volcano is not dead. It is active, and smaller, less catastrophic eruptions are far more likely to occur than a full-blown supereruption. Even a smaller hydrothermal explosion or lava flow could have significant local impacts. The story of Yellowstone isn't just about a potential future disaster. It's a reminder of the immense power simmering just beneath our feet. It highlights our planet's dynamic and sometimes violent nature. While the chances of a supereruption are slim, understanding the potential consequences is not about fear-mongering. It's about respecting the power of the natural world and appreciating the geological stability we so often take for granted. It encourages scientific monitoring and preparedness. So the next time you see one of those scary ashfall maps, remember that while the worst-case scenario is a real science-based possibility, it's also a very remote one. The more immediate story is the incredible science that allows us to understand and monitor these geological titans. But Yellowstone isn't the only force of nature with a story to tell. Sometimes, the most terrifying disasters happen not on land, but on the water, where a perfect storm of human error and natural fury can lead to mysteries that endure for decades. What really happened on the final voyage of the Edmund Fitzgerald? What was in that last cryptic transmission before the legendary ship and its crew vanished into the icy depths of Lake Superior that fateful November's Eve? We'll dive into that mystery next time on our upcoming mini-series, so make sure you stay tuned for that. If you found this exploration of Yellowstone fascinating, please hit that like button and subscribe for more deep dives into the world's greatest mysteries and phenomena. Don't forget to ring the bell so you won't miss our next investigation into the last transmission of the Edmund Fitzgerald. See you in the next video. Thank you so much for watching.